Hello, my name is Brock Osman. I have Monday labs at 10 a.m. and today we are doing the Lab 5 demo. And on the lab video, our demo told us to do the following multiplications, and I've already written down the results on what they're supposed to be. So we'll see if we can get the same results on our Quartus Prime circuit design thing. Okay, so take you over to my laptop over here and show you the circuit. So we have our A in and B in. I've only used A buses 0 to 3 because we only have 9 switches on our thing. I made them eight inputs just so in the future if we do need 8 inputs we can just ignore them for now and just use the first 4. And this is our add sub going into our add sub from lab 4, as it does say over here on lab 4. I wasn't able to change the name over there, unfortunately. I can do that later on, but anyways. And then this is our 4-bit multiplier over here, the A and B going in, with our S outs going into our TCBAs, with the function select over here. So if we have the function select to 0, it bypasses this and outputs the multiplication. And if we have this on 1, it doesn't go through here. It goes into this first one and gives us our adding and subtracting. And this add sub over here, 0, 1, we've done that last lab. And that should give us our final output over here. So I will show the 4-bit multiplier and the other ones, the TCBAs and all that, after I show all the demos. Alright, so our first one is A is 0, 0, 0, 0. Oh, let me show you the pins that I use actually. Okay, so this pin over here this is A0, 1, 2, 3. This is B0, 1, 2, 3. This is our add sub function, and this is our function select. So this last one selects if we're doing multiplication or the add sub one. Since this is down at 0, it's multiplication right now. This one doesn't really matter because we're doing the multiplication, but this would be our add right now. It would be add, this would be sub, but right now it doesn't really matter what we put at. Okay, so we set our A to 0, 0, 0, 0, and our B is 0, 0, 0, 1. And this should give us a 0, 0, 0, 0. So pins look great. Oh, this is our S0 to S7, by the way. Just saying. I'm not sure how far it goes. I think it goes all the way to LED 7. All right. So our second one that we're trying, I'm going to reset it real quick, is our A is 0, 0, 0, 1. So 0, 0, 0, 1. And our B is 0, 0, 1, 1. That should give us our just 1, 1 at the end, which is, I believe, 1 times 3, which gives us 3. Makes sense. Okay, so our A for this fourth one is 0, 0, 1, 0. So it's 0, 0, 1, 0. And our B is 0, 0, 1, 0 as well. So 0, 0, 1, 0. Alright, so this is a multiplication of 2 times 2, which should give us 4. And our 4 in binary is 0, 1, 0, 0. Well, 0, 0, 0, 0, 0, 1, 0, 0. So it's just 1, 0, 0 at the end. So we got that. And our final one is our A is 0, 1, 0, 1. So if we do 0, 1, turn this one off, 0, 1. So 0, 1, 0, 1. And then B is 0, 0, 1, 1. So 0, 0, 1, and 1. Which should give us, I forget what this is. I think this is 5 times 3. Which should give us 15, which is 1, 1, 1, 1. Which we have 1, 1, 1, 1 over here. So we can say that our circuit, the multiplication side works. Those were the only demo cases that we had on the lab video, so those are the only ones that I've done. I will now show you the circuit designs for, we'll start from add sub, then go into the multiplication, then the TCBA. Okay, so for our add sub, there's nothing really new. It's the exact same thing from our previous lab 4. I just changed the pins to be 8-bit inputs, just because the TCBAs were set them to 8 bits, so it doesn't really matter if we have extra bits anyways if we're not using them. Okay, so now this is one of the new stuffs that we did for this lab. So this is our 4-bit multiplier. We have our A in over here, our B in over here. The A's just get distributed into these AND gates for every single one of these full adder combinations. And then we have B0, B1, B2, and B3 getting inserted here. And we have grounds that go into the carry-ins. So we have A and B's ANDed, put into the X, A and B's added, put into the Y, ground into the C-ins, the C outs just carry over as an X input for the next one, and so on, and we get our 7-bit output. Okay, and finally, this is our TCBA. We have our 7 inputs into a bus, go from 0 to 7, those are 8 inputs, into this TRI. Well, they each go into a TRI, and we have the EN over here that gets input to the sides for every single one, and then we have our outputs going into our 8 bits output bus, and then we have the output as an 8 bits thing. Thanks for watching the lab demo.